Now let's take a look at a problem with continuous random variables. Now let's look at a problem if we have continuous random variable. And specifically, the random variable here is following a normal distribution. Just a brief summary of what is the difference between continuous random variable and a discrete random variable visually. Let me draw a figure. So on the left, we have the plot for the discrete random variable, and then on the right, we have the plot for the continuous random variable. And for the y-axis on both plots, that represents the probability of x takes some certain value. So on the discrete random variable, you can think of the x's values are countable values, so they're separate values, so they can be either 1, 2, 3, 4, like integers. But the probability for each of these will be like a bar. And sum of all these x's will be 1. But this is the requirement for both cases. But for continuous case, but on the continuous random variable case, if we're still looking at the interval 1 and 4, instead of having the separate bars there, we're going to have some lines across the values. So in here, the x can take any real number values from 1 to 4, and will have associated probability of that number. And we still have the restriction of all the probabilities of the x's will sum up to 1. But that was very superficial illustration of the difference between discrete and continuous random variables. If you want a more rigorous definition, you can search the Wikipedia or take a look at some statistical textbook. Now let's look at this problem. We want to find the probability that the actual market value is at least $171. And we are told this random variable for the market is following a normal distribution, and with the mean of 175 and the variance equals 25. So this is my typical notation for the mean and the notation for the variance. And additionally, the notation for standard deviation is sigma. To find the probability of having the market value at least 171, we want to use this formula, find the z statistic, which is x minus mean divided by the standard deviation. And then the x here is the value we are asked to find. In this context, the x would be the 171, and the mean is 175, and standard deviation is just square root of the variance, which is square root of 25, and we will have minus 0.8. So what this formula is doing is really doing the standardization so that this number x can be converted to the distribution which follows this mean 0 and with the standard deviation as well. Yeah, just let me restate that. So the formula is standardizing the x values such that we can see that x is from an associated standard normal distribution with the mean 0 and the standard deviation. So after this conversion, we will see the previously we want to find the probability that x is larger than 171. But now because we have do the conversion in the equivalent way, we can find the corresponding x that is greater than negative 0.8 from a standard normal distribution with mean 0 and sigma 1. Now to find this value using the appendix we have from the textbook, we want to do some further conversion. So let me just show you a graph about why we want to do the conversion. So let's say we have this normal distribution from mean 0, and let's say we have minus 0.8 here. So this expression, the probability that x greater than negative 0.8 is actually this area. But the tool we want to use from the appendix really gives us the value of the associated x is below that dashed line in the above. So in this figure, what the textbook gives us, or any normal distribution lookup table will give us, is the shaded area below the value that is associated with. So in this case, that's below minus 0.8. So how to get the expression for this shaded area below the negative 0.8 point? It's actually very straightforward given this graph. So since we already know that for any given probability distribution, the summation of all the probabilities will be 1. So in this case, what we have for this shaded area of the bottom figure would be 1 minus what we have for the above is x greater than negative 0.8, and that is equivalent to probability of x less than or equal to negative 0.8. Then we are ready to use the appendix lookup table. So this is the lookup table from the textbook, and for this problem, the z here is the converted one, so negative 0.8. And we first want to look at this column, the z column. So we find the value we are interested in this case, negative 0.8. So at this row, and also just another note, all these columns means the values at the second decimal places of z. And in this problem, we only get minus 0.8, which doesn't have any second decimal places number. So this 0.2119 is the we can just plug in that numbers. So the probability of x less than or equal to negative 0.8 is 0.2119. Then, so we want to, then for the problem, we want to get the probability that is really this guy. So we further do the conversion again, which will be 1 minus x less than or equal to 0.8, negative 0.8, and it's 1 minus 0.2119, and we get 0.7881. And we are done.